Hello, welcome back. All right, so in the last video, we looked at the condition of a particle moving along a straight line. We defined the two variables, position and its change or displacement, delta S, as particle move from one point to another on the line. Now let's continue with our definitions and define the next concept, and that would be average velocity. Assuming that the time between these two events I have shown here, when the particle was at S and then it displaced some amount delta S to go to S prime, some time has passed, so time delta T is time passed. What I can define as average velocity, V bar or V average. What notation do I? Let's go with V average. This we can define it as the displacement divided by time. How much we have displaced divided by how much time has passed between the two events. So for instance, let's do a very rudimentary example. Let's do an example. This is the straight line. Originally, let's do circle. I was at location 1 meter. Then I went to 2.5 meters. And the time between these events, delta T, is 2 seconds. I can calculate the average velocity to be 2.5 meters minus 1 meter. That is my displacement. So that is 1.5 meter divided by time passed, 2 seconds. That is 1.5 divided by 2, 0.75 meters per second. So this is 2 seconds. Let me be complete on the units, and that is the average velocity. Is my calculation correct? Yes, looks correct enough. So we are displaced 1.5 meters in 2 seconds, meaning that on average, I was displacing 0.75 meters for every second. And that added up to 1.5 meter of displacement in 2 seconds. Now this is the concept of average velocity. The question is, what happened in between? Was the particle moving always with this velocity? And a good example here is, imagine you're stuck in a traffic jam. You move in about, 1 mile down the road in 2 minutes. So you can calculate the average velocity to be 2 miles divided by 2 minutes, or 1 mile per minute. But you don't always move with that velocity. So your speedometer on your car doesn't always stick on that value. What usually happens, you move a little bit forward, then stop, then move with some velocity again forward, then stop. So the actual speed or the velocity of the car is fluctuating, is changing. And that is different from the average velocity. How do we calculate instantaneous velocity? So I have instantaneous velocity, or simply, we don't say instantaneous, just velocity. And velocity is, you can calculate it at every time. How do we do that? So imagine in the car example, instead of the 2 minute time interval that I was looking at, now I look at the shorter interval of 1 minute or 30 seconds or 1 second. I can calculate how much I move in every 1 second, and that should give me average velocity at the shorter time windows. And by making these time intervals smaller and smaller, so making my delta t approaching 0, the average velocity that I calculate in that tiny and tiny time window approaches the average I calculate approaches the instantaneous velocity. So this is limit. So I can actually write it in a more mathematical form, that instantaneous v is limit of delta t going to 0 of delta s over delta t. As I take shorter and shorter intervals, I arrive at better and better approximation of instantaneous velocity. And we have a very interesting notation for this. If you go back to your calculus notes, you will see that velocity becomes time derivative ds over dt. So time derivative of position. Let me write it down. V is, what did I write? Item, time. Time derivative of position. We, let me see, a few remarks. Unit of velocity is some unit of length divided by unit of time, meter per second or feet per second, and so on, kilometers per hour. That's one thing I wanted to say. Another thing, now I have forgotten. Notation wise, we can also write V is S dot, a dot on top. This is notation for a shorter notation for, let me write it, first time derivative. We can use this notation, very, very simple notation, to define time derivative. V equals S dot, S being the position, V is the velocity, instantaneous velocity. And I think that is all I have. I can't think of anything else to add here. So I leave you with definition of average and instantaneous velocity, and in the next time we'll look at the last one, that is the acceleration. So I'll see you then.